I'd like to introduce our next speaker, Michelle Hubbard, research scientist, pulse pathology, agriculture and agri-food Canada, who will be speaking about lentil anthracnose and what you need to know. Michelle is based in Swift Current, where her research focuses on anthracnose of lentils, ascochyta blight of chickpeas, and root rot in peas and lentils. She hopes to help pulse farmers find novel, practical, and sustainable ways of dealing with crop diseases. Welcome, Michelle.
Thank you very much for that introduction. So today I'm going to talk about anthracnose of lentil. And so first off, I have an overview of my presentation. So I'll be talking about first what is lentil anthracnose, some management considerations, and then because the focus of my current research is on fungicide insensitivity, I'll be focusing in on what that is and what the latest research has found, and then wrapping up by giving some information about what you can do to deal with this issue. So first off, anthracnose of lentil is typically in Saskatchewan the most important foliar disease in lentil, and it's caused by the fungus Calyptricum lentis or C. lentis. And the symptoms of anthracnose in lentil include stem lesions that typically start low in the canopy, so near the ground, and then if the disease gets more severe, work their way up. And then it can also infect leaves and gives the appearance of water-soaked lesions, like the picture on the lower left here shows. And as the disease gets more severe, it will cause leaf drop, so leaves falling onto the ground and detaching from the plant. And if the stem lesions get severe enough, they can girdle the stems or wrap fully around the plant, causing lodging. And that's what the picture here shows. And so anthracnose life cycle is importantly, the disease survives from year to year in the residue on plants in the soil and on the soil surface. And it does that by forming microscleridia, so these little black dots that you can see in the pictures of stem lesions. And those are protective structures that allow the fungus to survive for multiple years. And then within a growing season, anthracnose can infect multiple times. So as the lentil plants grow and get infected, and then the fungus reproduces and then produces spores within one season, those spores can then germinate, can then be dispersed rather to other neighboring plants and germinate and reinfect and again reproduce and multiply. So that allows the fungus to increase within a single season. And it also is important in the context of fungicide insensitivity that I'll get to later, in that the fungus can adapt to a fungicide. And so being able to reproduce multiple times in a season makes it easier for fungicide insensitivity to develop. Then the environment clearly will have an impact, as I'm sure you've all noticed over the last couple of years, on disease. And if it's more moist, then the disease in general and anthracnose in particular tend to be more of an issue. But then if it's cooler, as in under 15 degrees, disease that doesn't favor anthracnose. But obviously being super hot, like we saw last year, that also didn't favor anthracnose. So it's kind of that happy medium of over 15 degrees, but not incredibly hot, that is most conducive to anthracnose being a problem. And so to manage anthracnose, scouting is very important, and especially getting there early, because if you do decide to spray a fungicide, it's important to do it early, partly as a preventative, so before the disease really gets established, and partly to do it before the canopy closes so that you actually make contact with the lower parts of the plant where the disease is likely to be. If the canopy has already closed, the fungicide just won't get into where it needs to be within the plant. And then the other management strategies are things that you really need to do before planting. So be thinking about this time of year, such as rotation. It's not as bad as what we heard in the last talk with 6 to 8 years for Aphanomyces root rot, but still a 4-year break is recommended to give the residue time to break down and the pathogen time to die. And then variety selection can help with other lentil foliar diseases, but unfortunately for Anthracnose, there's 2 races, and race 0 is more virulent and is now more common because we really don't have commercial genetic resistance to it. And then there is resistance to the other race, to race 1, but that's not really dominant. So variety selection isn't a great tool at this point for Anthracnose. Really, the ones you want to keep in mind is rotation, thinking about whether or not you're going to use fungicides and using them early if you decide to use them. And I'll talk more about selection later in this talk. And then keeping your crop healthy as much as possible in terms of free of other issues like nutrient stress or weeds and that kind of thing. And then avoiding really dense planting rates, as that can make a more moist canopy that favors disease. And then that's really not known at this point if intercropping lentil with another crop could help, but intercropping does help with other foliar diseases. So it might be worth a shot if you're interested, and is certainly something that I'm interested in exploring in my research. So now to get into fungicides. So as I'm sure you all know, fungicides are compounds that can kill or stop the spore germination or growth of fungi. And they have many different potential modes of action and contain active ingredients. And so the active ingredients that we're interested in the context of Anthracnose are most importantly group 11s or strobilurins, and then to a lesser extent group 3, which are demethylation inhibitors, or group 7, succinate dehydrogenase inhibitors, and then contact-based actives. And so these different groups act in different ways, where group 7s and group 11s target fungal respiration, and then group 3s target cell membranes by inhibiting the sterol biosynthesis that goes into cell membranes. And so then how fungicide insensitivity develops is illustrated in this little diagram. So initially, there's likely to be some fungi. So within, say, a diseased plant, there'll be lots of different, quote, individuals of the fungus. And a few of them, a small proportion, will be just naturally insensitive. So that means they won't be harmed or will be harmed less by the fungicide. And the majority will be sensitive. And that's the way it will stay if you don't apply a fungicide. But if you do apply a fungicide, the majority of the sensitive fungi will be killed and the insensitive won't. And so then the proportion shifts. There's likely to be less pathogen overall, which is great for disease management, but a greater proportion of them will be insensitive. And then you allow some time, and the fungus will naturally continue to reproduce, more so if the environment is favorable. And then the proportion continues to be a higher level of insensitive in the population. So then if you imagine in this diagram, if a fungicide was applied again, most of those black dots, black squares would go away, and there'd still be all the red ones, all the insensitive. And so now the proportion would shift yet again, and it would be still like a higher percent of the pathogen would be insensitive. And so this can continue through multiple cycles of fungicide application. And the risk is also higher depending on what group of fungicide you're using and on characteristics of the pathogen. And so group 11s are high risk because it's quite easy for fungi to develop insensitivity. It's just a single DNA change can confer that. And then group 3s and 7s, the risk is medium, and contact-based fungicides, the risk is low. And so for controlling anthracnose of lentil, by far the most commonly used active ingredients are group 11s. And so the information is from, this is from a survey that I led in 2020. And you can see of all the different fields, and the N numbers here are the number of fields. So for example, 26 fields had Delero applied, which has a group 11. And also 26 fields had the fungicide Elatis applied, which also has a group 11. So you can see from this that not only are there a lot of fungicides that contain group 11s, and limited options of those that don't, but the fungicides that people choose to use are almost all contained a group 11. So that also elevates the risk of group 11 insensitivity developing, and hence it was the focus of the research that I'm going to tell you about. So I've led field surveys to look at this issue in 2020 and in 2021. And so 2020 being wetter than 2021, more fields were surveyed and the disease pressure was much heavier. There was a higher incidence. So if a surveyor looked at 10 plants in 10 different sites within the field, it was much more common to find some disease. So that's like 4.1 out of 10 is about 40% of the time, or the plants had some disease. And then the severity was over 6 on a 0 to 9 scale. So that's relatively high. Then in 2021, when it was extremely hot and dry, there was very little disease. So a severity of only 1.1 on a 0 to 5 scale. So that's, the scale is a little different, but the disease was just very, very little. Not because anthracnose has gone away, unfortunately, but because it was a hot, dry year, which of course comes with its own problems. Then this slide shows some work done by Insight Plant Health and Dr. Dave Greenshield that was commissioned by the Saskatchewan pulse growers. And here, Insight Plant Health was looking at the impact of various different fungicides on the disease severity in lentil anthracnose in a growth chamber. So this was not in the field. And what they found is that any fungicide did lead to less disease than no fungicide. So the yellow bar off to the right is no fungicide, and the x-axis is disease severity that would go all the way up to 5. So the disease wasn't all that severe. And then here's if we look at the exact same data, but just breaking it down by the active ingredients. So across the bottom, there's nothing. And then group 11s by themselves tend to have higher disease if we're just sorting things by which active ingredients there are, down to on the purple bars on the other side have contact-based fungicides in them. And then Insight Plant Health rather also did work where they had isolates that were known to be either sensitive or insensitive to group 11 fungicides. And I should mention that if a fungus is insensitive to one group 11 active ingredient, it's insensitive to them all. There's a single tiny little DNA change, a single base pair change that can lead to a high level of insensitivity to any group 11. And so here, when there's a star above the pair of graphs, so the dark green graph will be the disease severity in plants that were treated with anthracnose that should be sensitive, so it should be impacted by group 11. And then the lighter green bar is the disease severity in insensitive plants that were inoculated with insensitive anthracnose. So not surprisingly, when a fungicide that only contained a group 11 was applied, then it wasn't well controlled by a group 11 only product. So if we look, for example, at the headline example, there's more disease when headline was applied to insensitive anthracnose versus sensitive, and that makes sense. Then when there was a group 11 and a group 7, you'd think that perhaps the group 7 would control anthracnose, but from these graphs, that's not what we're seeing. Then this slide just shows anthracnose growing on plates and shows that so the red is insensitive, and the control bars are if there was no fungicide added to the plates. And then you can see if it's insensitive to a group 11 fungicide, so the fungicide was mixed into the plate, the fungus grew slightly less, but it grew. But then in contrast, if the fungus was sensitive to group 11 fungicides, they grew very little or not at all. So the little squares that you see in the center of these Petri plates are chunks of agar on which the fungus is growing that came from another plate. And so those are there, they're not going to disappear, but the fungus isn't growing out. And the G143A, that's the single base pair or the small DNA change that I was mentioning that leads to cross resistance to all group 11 actives. And so since it's just a single change, then it can happen relatively easily. And that's why there's a high risk of insensitivity developing to group 11 fungicides. Then here's some more results from the 2020 survey. And so we would do a test that was based on extracting DNA from diseased lentil samples. And the possible results of this is either the sample contains only insensitive anthracnose, it contains only sensitive anthracnose, or it contains both. And both is what we call mixed in this graph. Or occasionally we'd get a result that was hard to interpret and we'd say we're unsure. And so at this point, we've analyzed results from up to 4 sites per field, depending on there had to be enough disease in the field to get results. So if there was no disease in a site in the field, we just couldn't get results. But the main point here is that, as you can see, the orange bar, the insensitive, is quite a bit taller. That's by far the most common result, is that from sites within that both overall fields and sites within fields, the most common result was that there was insensitivity. Next most common was sites that had some insensitive and some sensitive. So if you remember back to my picture earlier with the red and the black dots, that's like a mixture of the two. And then there were some field sites where there was only sensitive anthracnose. So basically that shows that all around the province, there's a lot of insensitivity out there. And we do have results from 2020, 2021, hopefully coming soon. Then another aspect of the survey was looking at the variability within fields. So as I mentioned, we analyzed up to 4 sites per field. So this graph is only from fields where there were 4 diseased sites to look at. And so here, again, there's a whole bunch of possible results from being only insensitive, mixed, only mixed, or only sensitive, and then the various combinations of that within the 4 sites. And so there was not, of all of the fields, there was only a few, only 6, that where there was only sensitive. So that's a minority of fields. If you sprayed the whole field with a fungicide, with a group 11 containing fungicide, would you expect results from that? Would you expect like the whole, every site in that field was had sensitive anthracnose? And then many fields, all the others, had some. So there was 10 fields that were only insensitive, and then the next most 14 fields that were both insensitive and mixed, and then all the other fields had some insensitivity in them. So that's reducing the likely effectiveness of a group 11 fungicide. The one piece of good news was that if you looked at sites, the level of disease severity, it was actually lower. The disease was less severe where there was insensitive isolates. So that's a little bit surprising and might indicate that there's a cost to the fitness of the fungus to have that small DNA mutation that confers insensitivity. And so that brings me to my future plans for the research. We're working on screening for insensitivity to especially group 7s. If you remember the work by Insight Plant Health, there's a suggestion that perhaps group 7 is not working as well as it could, or isn't that effective against anthracnose. So we want to look into the possibility that that insensitivity to group 7 fungicides has also developed, and then eventually looking at insensitivity to group 3 fungicides. And this will be done on plates based on the growth of the fungus. Then I'm also planning a survey for 2022. So I will be putting up a slide about how you can participate, because we need people to sign up. And I'm especially looking for agronomic information, so information about what fungicides were applied in the different fields. And then, as I mentioned, we're working on looking at if there's a cost to how well the fungus does if it's insensitive. And then, as I'm sure you're all wondering, what you want to take away from this meeting is what can you do? So first off, I would suggest assume that you have insensitivity and to group 11 fungicides, and take that into account when you're thinking about how you're going to manage anthracnose in lentil. And so then if you apply a group 11 fungicide, really try not to apply 2. So if you apply a fungicide that has group 11 as either the lone or a combination active, don't do that twice. Do it just once within the growing season. If you feel like you need to apply a second fungicide, choose something that doesn't rely on group 11 at all. Consider non-group 11 active ingredients, especially the contact-based ones. And if you decide to use any fungicide, try to start early before the canopy closes so you can get good contact and preventative action. Keep records of what you do, and then use other good management practices like good crop rotation to allow anthracnose to break down. Maintain a healthy crop as much as possible, so things like good weed control, avoiding herbicide residues due to drought, all of those other good things. And consider trying intercropping if that interests you. And then I would really appreciate it if you take part in the pest monitoring surveys that the Ministry of Agriculture does. And so this is a QR code that you can actually scan now, or you can go visit the website later. And so if you sign up, this is what it should look like. And with that, I'm coming to the end of my presentation. And so I'd just like to acknowledge the other members of my team, as well as the many people who did the surveying work from the Ministry of Agriculture and from private companies. And with that, I'll be happy to take any questions.
Hi, Michelle. I'm wondering, is there any research that says intercropping does lower the infection rates?
Okay, thanks for that question. So not for anthracnose of lentil. For other foliar diseases, yes. So like, for example, I have research on ascochyta blight of chickpea that shows that intercropping chickpea and flax helps. And then there's research on other foliar diseases showing that, and I don't recall seeing any research saying that intercropping hurts with disease management, and in some situations it helps. And the possible reasons for that could be a barrier to disease spread, could be perhaps a drier canopy, or perhaps other mechanisms.
Michelle, we have an online question from Kathy Kerr, and she asks, how long can anthracnose live in the soil?
Okay, thanks for that question. Well, it will start to break down just after 1 year, but basically after 3 or 4 years, it should have gone down to a pretty safe level.
I'd just like to know, what do you recommend for intercropping?
Like what companion crop?
Yeah,
Well, for my first thought would be flax. And the reason I would say that is that you still have fungicide options that are registered for both, like Priaxa or Diax for sure. And also, and another reason I would say that is that I know some people are trying it, and that it's possible, at least if you use a large green lentil, you could separate the seeds based on size. That's another super important consideration, that you have to separate the seeds somehow. Another companion crop I'd consider would be oil seeds. So canola or mustard or maybe camelina. And there again, because you can separate the seeds. You could try a cereal, but a concern with that I've heard is grassy weed control, but I know people are trying it. And so yeah, that would be my recommendation. Is flax would be the first one that comes to mind.
If lentils become, I guess, insensitive to group 7s, will it be insensitive to all group 7s?
Oh, excellent question. Excellent question. Thanks for asking that. No, not necessarily. They might be, but might not be. And so for the work that we're getting off the ground, we're like based on the fungicides that people used most commonly in 2020, we're choosing which group 7 actives to use. So in order to, but it's a long, slow process to test them. So that's one other reason why we need people to participate in a 2022 season, to get an idea of which group 7 actives make sense to test and where we should put limited resources. So thanks for the question, and please consider taking part in the surveys.
Thank you for that important information, Michelle. Appreciate it.